Hello, good people. Welcome to video 2 of L'Hopital's rule. I did want to take just a moment. For example 2, we worked out the limit. We checked in purple that it was an indeterminate form, 0 over 0. In blue, we carried out L'Hopital's rule that says take the derivative of the top over the derivative of the bottom, take the limit again. We got an answer. The answer was 3/4. I just wanted to take a couple of seconds here to show you, or to, take the time to show you what does the graph of this look like and does it verify our answer? Because what this is saying is if I were to graph this function that we're looking at and I look near x equals 0, my y value, my function value will be 3/4. So I go to my calculator and I already preloaded this. Let's do a zoom 6. So this is what the graph looks like. And I don't know if you can tell, it looks like there's a missing point right at the y-axis here. So I'm going to zoom in a little bit and see if I can get a better look. And if I press trace, you'll definitely see that for this blue equation, which is the equation we're talking about, at x equals 0, there is no y value because there's a deleted point. However, if I go a little bit to the right, at point 1, there is a y value, and it's 0.78. And if I go a little bit to the left, at negative 0.1, there is a y value, and it's 0.72. So it kind of makes sense that at x equals 0, or maybe the better way to phrase it is, as I get closer to x equals 0, we're heading towards 0.75. And that's just, I guess, a visual confirmation of what the analytical work told us, right? Symbolically, we're saying, hey, this is the answer is 3/4. What does that mean? Well, that means that the graph is getting closer and closer to y equals 3/4 as my x's get closer and closer to 0. I wasn't able to figure out what it was by doing direct substitution because there is no point there. But it should be there, or rather, it should be approaching 3/4. Okay, just a quick aside to kind of make sure we understand what we should see, what the limit is telling us we should see. But as I look for examples 3 and 4 here, and then we'll come back and do examples 5 and 6, we're given a graph. It's the graph of f, and it consists of 3 line segments. We're given the function g as well as g prime and g double prime for selected values in the table. And we're going to use this information to answer the following. So we're going to take the limit here of this function. How do we take a limit? Take the limit of the top. And we're going to take the limit of the bottom. Well, as I finish writing the denominator limit, I think I can figure this one out. If I substitute negative 2 in here, that'll be negative 4 plus 4, that would be 0. Now for the top, if I substitute negative 2 in here, then I'm looking for f of negative 2. I'm looking for the y value at x equals negative 2. So at x equals negative 2, the y value is 1 minus 1. Oh, that also equals 0. So this is a candidate for L'Hopital's rule. This is now meeting the conditions for me to use and apply L'Hopital's rule. So I'm ready to do L'Hopital's rule. The limit as x approaches negative 2 of the derivative of the top, which would be f prime of x, minus the derivative of 1, which is 0, over the derivative of the bottom. The derivative of 2x is 2, plus the derivative of 4 is 0. So if I can figure out what f prime of negative 2 is and divide it by 2, that's going to be my limit of this original function that they set up for me. So f prime at negative 2. F prime of negative 2 means the slope at negative 2. Well, the slope at negative 2 is negative 1/2, because I went down 1 over 2, so negative 1 over 2. And then I'm going to divide that by 2, so that's going to be negative 1/4. This is the answer to that limit question in example number 3. I have to check for indeterminate forms. If it's not an indeterminate form, I cannot use L'Hopital's rule. L'Hopital's rule is only a shortcut whenever we have a 0 over 0 situation after doing direct substitution, or if we have infinity over infinity. If I don't have those situations, I cannot use L'Hopital's rule. When I look at number 4, I need to verify that it is eligible for me to use L'Hopital's rule. And I can tell without finishing writing the bottom that, yes, this one is, because we're going to get 0 when I plug in 4. In the numerator, I'm going to take the limit as x approaches 4 of g of x plus e to the 2x minus 8. Whoa, that's a lot. Well, if I plug in 4 here, I need to know what g of 4 is. G, oh, I lost it. Where did it go? Oh, I really did lose it. There it is. G of 4. G of 4 is negative 3. Oh, I think I left this 3 out of my setup here. When I substitute 4 into the exponent, 2 times 4 is 8. 8 minus 8 is 0. E to the 0 is 1 times 3. Well, that would be just positive 3, and that will also give me 0. Great. So it is eligible for me to use L'Hopital's rule. So we're going to take the derivative at the top over the derivative at the bottom, and then do the limit all over again. Take the limit as x approaches 4 of the numerator. I don't know what happened there. Let's see. The derivative of this would just be g prime of x plus, the derivative of this. Well, 3 is a constant multiple, so I'm going to just write it there. The derivative of e to the 2x minus 8 is really taking the derivative of e to the something, which is a chain rule, right? Because there's an inside function. So the derivative of that would be e to the 2x minus 8 times the derivative of the inside, and the inside is this, so that's 2, over the derivative of the bottom. Well, the derivative of 4 is 0, minus the derivative of x is 1, so 0 minus 1, that would be negative 1. And so now I need to do direct substitution and see what we get. Uh-oh, I'm running into this one. Why don't I put it down here? G prime of 4 plus 3e to the 2 times 4 minus 8 times 2 all over negative 1. All right, so I need to know what the derivative of 4 is. What's the derivative of g at 4? The derivative of g at 4 is negative 1. G prime, when x equals 4, is negative 1. Plus 3 times e, well, this is going to be 0 again, times 2 all over negative 1, which is negative 1 plus 6 divided by negative 1, and that's going to give me to negative 5. 3 times 1 times 2 is 6, and then plus negative 1 is 5. I'm sorry, that's positive 5, and then divided by negative 1, then it is negative 5. But I found the limit value. This is what the limit is. I was able to apply L'Hopital's rule and not have to freak out about a way to reduce or find a special technique for me to find the answer. If it's eligible to do L'Hopital's rule, use L'Hopital's rule, please.